Okay, so let's just make sure that my sound level is correct, which it is. This is Dirk, and I would like to give people a quick little sampler on how to use the application I call Celestia, and which its programmers also call Celestia. This is an application that allows us to take a view of the solar system or perhaps near space, regions close to our solar system, as they would be seen by an astronomer, except, of course, that everything's a simulation. So this is a computer program which you can find on the internet and download either for Windows or which you can custom compile for Linux, as I have done. I've custom compiled this. What may be a bit perplexing about this program is how it works and therefore what its images mean. Right now, you're looking at a planet that you're very familiar with called the Earth, and yet one question that you may ask is, how did I get here? I'm using the middle scroll wheel of my mouse to make the Earth seem to get smaller or bigger. When I'm using the scroll wheel of the mouse, I'm actually positioning a virtual camera either closer to the Earth or further away from it. The field of view that I have has been set to some constant angle, and I'm not even going to bother to look that up right now because I find that question to be a distraction that I just thought of. Because my focus is on how do we navigate our solar system or near space using the application Celestia. So the Earth is centered. Well, one of the easiest things that we can do is on our numerical keypad, we can push the right button or the left button in order to pan the mouse. And we find that the sun seems to be way out there in the distance, whereas the Earth is so close. And what we will discover as we experiment a little bit more with accelerating time is that camera position and camera angle are two different things. I am using the arrow buttons on the numerical keypad to change the camera angle, not the camera position. So the thing is, there's a navigation menu here, and what the present selection can be determined by left clicking on an object. Since the Earth was selected, when I left click on it, it remains selected. It's just that I just centered it. So the navigation default is to center the selection. Now, there are various other options. You can go to a selection, and I'm going to talk a little bit more about what that means. You can follow the selection, or you can track the selection or sync orbit. Okay, I'm going to explain what those terms mean because they are ultimately important. Right now, I could be positioned in some imaginary position above the Earth, and yet the question could seem relevant as to exactly what would happen if I speed up time. The letter L accelerates time, the letter K slows down time, and the letter J reverses time. So if I hit the letter L once, I've doubled the time frame. I can increase the rate at which time elapses enormously. And you'll notice that the Earth stays centered. Why does the Earth stay centered? Because I'm also following the Earth. So that means that no matter where my camera is positioned, not only do I see the Earth in front of me, but as the Earth's orbit around the sun is changing, my camera is moving with it. Now, my goal could be to go someplace else entirely, and doing so performs a number of actions. There are special menus here as the solar system browser, where the Earth has a moon, where the moon is equipped with one artificial satellite, where Mars has its moons. Well, guess what? Mars has 4 moons. Okay, so doesn't have 2 moons anymore. It has the Mars Odyssey and the MGS, which are listed as moons, but which are actually spacecraft. What I'm going to do is I'm going to do something radical here. I'm going to click in navigation. I'm going to go to the star browser. I've decided I'm bored with our solar system. I want to go to the star that's known as Proxima, also known as Proxima Centauri. And down here we have a center button. If we center Proxima Centauri, we're panning the camera. That means right now, somewhere in the center of where the camera is, here is Proxima Centauri. Well, that's not what I wanted. I didn't want to center the camera angle on Proxima Centauri. I actually wanted to go there. And when we go there, a sequence of actions will take place. We will be disconnected from the object which we were previously following, and a little camera magic takes place. So we can watch a little animation here. There's Proxima. It's a disappointingly small star. I'm using my mouse wheel to get closer to it. And we notice that it has a rather pinkish color because its surface temperature is not that high. So lower surface temperatures mean that the color of the light is going to be rather pink. And so now, in a rather primitive animation, the camera position has flown to Proxima Centauri, and that means the camera position is also following Proxima Centauri, except that in Celestia, the distant stars don't move. So actually, sorry, that was an accident. Actually, following Proxima Centauri doesn't do us any good because according to Celestia, it doesn't move. But it can sometimes be important that we approach the Earth from the direction that Proxima Centauri would be seeing the Earth from. So I can look at the solar system browser. It doesn't exist for Proxima Centauri. I can go to the star browser. I can click on, what can I click on? There's nothing to click on. It only shows me non-Earth star systems. Okay, so we go into navigation and we go select Sol. We select the Earth, even though we can't see it in a browser anywhere. Select Sol. The Sol is another word for our sun. Our sun is called Sol. We select it. The information in the upper right-hand corner changes, and we center the selection. So this is what our sun looks like as seen from Proxima Centauri. And if we now say with our navigation that we want to go to this selection, the distance that we had to our native sun changes rapidly. And now we're facing the sun from a completely different angle than any angle that we were facing it from before. So this can be a bit confusing because we did not expect that we would be outside of the plane of the solar system. But Proxima Centauri is outside the plane of the solar system. So the next thing that I would want to do is I would want to navigate, and I would want to look at the solar system browser now that we're back in our own solar system. And I can do a little trick. I can navigate to the moon. And once being positioned above the moon, as seen from my previous position, I can select our sun again, and I can say, go to the sun, right? And now, from wherever the sun is, I'm much closer to the plane of our solar system. I can select the Earth again, solar system browser. I can go to the Earth, as from where my previous position was. And I can, if I want, go back to solar system browser. I can go back to the moon, and then I will be in a position above the moon as seen from much closer to where the Earth was. So now I'm looking at the moon, and the orbits of the planets form a backdrop against the moon that at least pretty much crosses through the center of the moon. And if I use the left and right arrows not belonging to the numerical keypad but the regular left and right arrow keys, I can even bank the camera a little bit. I can roll the camera so that the orbits of the planets behind the moon seem somewhat level, seem somewhat horizontal. I'm close to the moon's surface. And now I would like to do something that I've always wanted to do. I would like to see the Earth as it would be seen from the surface of the moon. And it's a little bit counterintuitive how to accomplish this. The thing we want is sync orbit selection. What this means is I'm going to accept whatever distance from the moon I have, and I'm going to pretend that I'm in synchronous orbit about the moon. So we don't see any immediate difference because when we're in synchronous orbit around an object, we should always be facing that object from a direction that rotates with the object, which means that I can now center the camera position on the Earth. You see, I can actually have a synchronous orbit around the moon, and yet my camera position could be a fixed position in space, such as the Earth. So I'm going to just do my best to center this a little bit because I want the quality to be as high as possible. And now I'm going to accelerate the clock a little bit because what I was looking for is what would it look like to be on the moon, roughly facing the Earth. So as the moon orbits the Earth, it approximately faces in the same direction, but only approximately. The Earth isn't completely stationary according to this simulation. The Earth is moving side to side, as well as moving up and down within our two-dimensional image. The moon is orbiting the Earth, and the position of our camera is synchronized with the rotation of the moon. So that this is what the Earth would be doing if we were on a fixed position on the moon, looking back at it, and yet if the time was moving, how fast is it moving? 262,000, no, 524,000 times faster than time normally advances. This should repeat indefinitely. So even though the moon is tidally locked to the Earth, its angle with respect to the Earth is not perfectly constant, because otherwise the Earth would not be moving left to right in this view. The Earth is moving not only left to right, but also vertically as far as this two-dimensional position is concerned, and the moon is orbiting the Earth. So anyway, that's how you get what you want with Celestia. You're synchronized in your movement with the moon, and you're facing the Earth, and you're discovering to your great disappointment that the Earth does not seem to have a fixed position according to your center of view. I'm all done. Thank you. That's about it for